This is the front of your little book here. As we go through it, we're going to do several things. So this front side shows you kind of the different types of exponent operations, I guess you could say, that we'll come across. On the inside, what we're going to be doing is we're going to take these problems that are all listed. You have several problems for each type. We are then going to write them out in their expanded form. So we're going to list out all the variables you see without the exponents. And then on the other side, you're going to be simplifying them. So reducing it down to an exponent with, or sorry, a variable with an exponent. On the back side, we may get to talk about this tomorrow. These are kind of your rules or your cheats. If you see patterns as you go through and work these problems out, we can fill in these rules. If you don't see patterns, it doesn't matter, because if you expand it, that's the best way to see it all happening. Anyways, so looking at the first part on the inside where it says the expanded form, I need to make this nice and big. I know you guys don't have a whole lot of space, but try to write small and keep this in here. That way it's organized by type. So the first problem that we have is problem number 1. And again, on this side, we're writing the expanded form. So I have x to the 5th power. If I have that 5th power, how many x's does that mean that I have? 5. And this is kind of blurry. So I'm going to list out my 5 x's. That exponent tells me that these x's are attached to each other how? Multiplication. So all of them are being multiplied together. Okay? So this is the idea on this side. You're expanding it out, and then on the other side we're going to simplify. So if we go over to the other side, follow it over problem number 1, where it says simplify. It's going to be kind of hard for me to show both at the same time. There we go. That works. So for problem number 1 on the simplified form, simplifying it is just listing your variable, your base item, with an exponent. So what was the variable or the base that we used here? We used a variable that was x. How many times did we list it out? 5. So what exponent do I use? 5. That's your simplified form. Obviously, it's exactly the original problem. They don't end up that way normally. That was just an example to work off of. So let's look at problem number 2. Problem number 2 on the expanded side, again, I have my paper kind of folded over to see both at the same time. On the expanded side, I have x to the 5th power. So how many x's am I going to list out here? 5. So I'm going to make my list. They're all attached through multiplication. Then I have x to the 3rd power. So how many x's is that? 3. So I'm going to list out those 3. Those 3 are all attached through multiplication. If I look at my x to the 5th and x to the 3rd in the original problem, they are also being multiplied together. So I'm going to put that multiplication symbol in my problem to connect them. Again, they were multiplied, so I'm putting that in. So now my simplified form on the other side of your little book for problem number 2. My simplified form, what's the only variable we're dealing with here? X. So I'm going to write my base, my variable of x. How many times do I have my x listed? How many times is it being multiplied? 8 times. So what exponent do I get to use? 8. X to the 8th. Okay, let's look at one that's maybe a little more challenging, problem number 4. So problem number 4 on the expanded side, we have 2x to the 3rd times 3xy squared. So I'm going to list out, I'm going to expand the first part, 2x to the 3rd power. How many 2's do I have here? 1. Is there any exponent with the 2? No. I mean, you could say there's a little exponent of 1, but we won't get into that. So I have a 2. If I have x to the 3rd power, how many x's is that? 3. So I'm going to list those 3 out. How is that 2 attached to my x to the 3rd? Multiplication, so I'm going to put that symbol in here. Then I have another multiplication symbol connecting 3xy squared. So I'm going to make sure I put that in my expanded form. In the second piece, does that big 3 have an exponent attached? No. So how many times do I get to list it? Once. How many x's do I have? 1x. And then in this case, I have y squared, which is how many y's? 2 y's. How are 3x and y squared all attached in the original? Multiplication. So I'm going to make sure I put in all those symbols. So now I have it expanded. I have it written out. We have 2x to the third power times 3xy squared. On the other side of your paper, we are going to simplify this. So we're going to try to condense it down. Let me fold my paper real quick so I can see both. Don't fold yours all crazy like mine. Just doing it so you can see them. All right, so if I want to simplify this out, the first thing I have here is a 2. Do I have any other big numbers in my problem? I have a 3. How are they attached? How's everything attached? Multiplying. So 2 times 3 is? 2 times 6, because we're multiplying, so we get a 6. Now I have an x. How many x's are all listed in this problem? 4. They're all being multiplied. So when I write my x, what exponent do I get to use? 4. It shows that it was multiplied 4 times, or listed 4 times. I also have y's in this problem. Y squared. There's only the 2 being multiplied together, so I write y squared. That would be my simplified form. Okay. In a moment, you're going to come back and complete the remaining problems on this section, but we're going to jump down to the next part. The next part now are problems that have parentheses. We're going to look to see how does it operate, what happens when you have a parentheses in your problem with exponents. So problem number 1, we have ab to the third power. That ab is your base. Okay? It's the thing holding the exponent in the air. So ab is our base now. It's raised to the third power. That third power, that exponent, means how many of those bases do we have? We have 3, right? It tells you how many of your base is listed. So I'm going to list out my base 3 times. So I have AB. Your exponent means my list. My exponent means these are attached how? Through what operation? Multiplying. So I have AB times AB times AB. Okay? How are the A and the B attached to each other? Multiplication. So I'm going to put those little dots in there as well. So everything in this problem is attached through multiplication. So if we want to simplify it, we're going to use our exponents to show that list. How many times is something multiplied by itself? So I have 2 different variables here. First off, I have an A. How many times is A being multiplied with other A's? 3. So I write A to the third. I also have a B. How many times is B being multiplied by another B? 3. B to the third. So that would be my simplified form. A to the third, B to the third. Okay, let's look at problem number 4. Problem number 4, a little more challenging. Here we have 2m n to the 4th power raised to the 4th power. So our parentheses are telling us that we have our base. Our base in this case is 2m n to the 4th power. The exponent on the outside is telling us to write this base how many times? 4 times. So I'm going to list out my base 4 times. I have 2m. Inside of my base, though, I have n to the 4th. So how many times do I actually have to list this n out? 4 times. So there's one base. We said this base has to be listed 4 times. So I'm going to multiply it with a second set. I have 2m n to the 4th. I'm going to list it a third time. And I'm going to make my list underneath because I ran out of space across. So a third time, I have 2m n to the 4th. I have to do it one more time because we were supposed to have 4 sets. So I have 2m n to the 4th. Hope if I write them all. How is all of this stuff in the problem connected? Multiplication. All of it's being multiplied together. If I wanted to put all my little dots in there, I could. If you don't need all those little dots, you don't have to write them in. So this is one reason why we use exponents, and this is one reason why there's cheats that we're going to talk about on the back, because this process gets very, very long. The bigger your exponents, the longer this process. So now we're going to take this information, we are going to look to simplify it. So if I wanted to simplify it, again, don't mind my folding, the first thing I have here is a 2. Do I have other big 2's? Yes. How are they all connected? Multiplication. So what is 2 times 2? Times 2? 8 times 2? 16. My big number now becomes 16. The next variable I have is an m. How many m's do I have multiplied together? 4. So I write m to the 4th power. The next variable I have is n. How many n's are all being multiplied together in this list? 16. You have 4 plus 4 plus 4 plus 4. If you counted them all up one by one, you'd get 16. It's kind of interesting here. In the original problem, I had n to the 4th power, and I had an exponent of 4. What is 4 times 4? Interesting. I had a plain m, and it ended with what exponent? 4. Kind of interesting.